Hi there, welcome to this video. This is 11-4, and we are talking the ambiguous case of the law of sines. Just means unclear. Is the triangle I have, or the given information, is it one triangle? Is it two triangles? Is it no triangles? So we're going to go ahead. I'm going to assume that you already know how to figure out how many triangles exist. Okay, if you need to acquire that information, go ahead and go back at a previous video or previous notes and find that. Otherwise, we're going to go ahead and dig into some examples. Here is the step-by-step process. You can pause this video and read through these if you need to, or just make sure you refer to them on your notes if you need to, okay? All right, so here is our very first example, and we're asked to determine how many triangles exist. We got to do that first. If the triangle exists, find all unknown measures, and when we are rounding, when necessary, round side measures to the nearest tenth. And we want to take our angle measures and we want to round those to the nearest degree. All right, so step one, I need to determine the height of this triangle. And remember that that is calculated as b times sine of a. So our b value, 18.7 centimeters, okay, times the sine of a, which, I almost wrote a, it's 19 degrees, okay. And calculating this is approximately 6.1, and our units here are centimeters. Okay, so I'm going to go ahead and I'm going to just draw a general representation, and pardon my lines if they're not straight. I don't have my line tool. Here's the first side. Okay, let's call this A. Our angle's 19 degrees. That's pretty low. Okay, there's my side. This is side B. This is 18.7. Okay, and our height, which is here, okay, that's about 6.1. So now I need my other side, which is side A. It's 16.2 centimeters. And I always tell my students, look, okay, from this vertex right here, which is this vertex is C, okay, this distance is 6.1. Okay, so to go over here, this is 18.7. Well, 16.2, and I'll draw this in a different color, fits in between, right? Okay, so what I hope you see is one triangle right here, right? And I'll put that down here. So we have, I'll say, we have this triangle over here. Okay, and it looks something like this. All right. Okay, then what I also have, if it fits in between here, right, I hope you know that this is two triangles. So two triangles exist. Okay, that's part of it, right? I don't like that box. Okay, so if this is 16.2, I can go ahead and generate another triangle. It's over here, 16.2. So now I have another triangle, right, which is all the way over here. So I'm going to draw another triangle. Okay, and that looks something like this. Okay, and I'm going to call this one triangle 1. I'll show you why I'm doing that here in a second. I'll call this one triangle 2. Okay, this is A. This is what I will call B1, and this is what I will call C1. Over here, this is A. This is what I will call B2. This is what I will call C2. Okay, so we're going to need to go ahead and find all the missing angles. Now, I do know, right, that this is 19 degrees. A is 19 degrees. I do know that this side is 18.7. And I do know that side A on both triangles, in fact, is 16.2. 16.2. So we're going to start off with triangle 1. Now, why do I want to start off with triangle 1? Well, it's because to find an angle, we're going to have to use inverse trig. When you do inverse trig, your calculator is only going to spit out acute angles. So because B1 is acute, that's why we are starting, right? So I'm going to say start with acute B. angle B, right? And that is because it's tiny, right? It's small, it's acute, that's why. So you're gonna start with that one, okay? So that's kind of your first step here. So I'm gonna say find the measurement of angle B1. Okay, how do we do this? Well, this is law of sines. I know that the sine of 19 over 16.2 is equal to sine of B1 over 18.7. Got to solve for B1. Okay, so I'll cross multiply. 18.7 sine of 19 is equal to 16.2 sine of B1. I'll solve for sine of B1 by dividing by 16.2. Okay, and then to solve for B1, I have to go ahead and do inverse trig. So sine inverse of 18.7 sine 19 all over 16.2. You plug this in, and your answer is approximately 22 degrees. Okay, so I know that this angle right here is 22 degrees. All right, so what about angle C? Well, how many degrees are there in a triangle? 180, yes. Okay, so next we have to find the measurement of, of angle C1. It doesn't like being zoomed in that far sometimes, so it will say, hey. Okay, so find the measurement of angle C1. All right, so the measurement of angle C1 is equal to 180 degrees minus the two angles that we have, right? 22 degrees and 19 degrees, leaving us with 139 degrees. All right, hey, I found two of them. The only thing I have left now to find, right, is this side, the little c. Okay, so C1. All right, so next I have to find, I'll say C1. Okay, well, again, I'm going to use law of sines. So I have 19 over 16.2, so sine of 19 over 16.2 is equal to the sine, okay, of whatever that angle is, so 139 over side C. You could say C1 if you want. All right, so C1 times sine of 19 is equal to 16.2 times sine of 139, making C equal to 16.2 sine of 139. Man, my hand cramps during this lesson because there's just so many calculations. Okay, and what we get is approximately 32.6 centimeters. Okay, so hey, I have solved one triangle, right? I know that this side is approximately 32.6 centimeters. All right, now we have to do triangle 2. Don't freak out. Triangle 2 is so much easier, and I'll tell you why. Well, it all goes back to our knowledge of this triangle right here. Now, I want you to envision, right, with triangle 1, what we did was we calculated this angle, and I'm going to switch over to a different color. We calculated this angle right here, right, which was 22 degrees. Okay, so if this side, though, in blue, 16.2 is the same as this one, then aren't these the same? It's an isosceles triangle. And an isosceles triangle, that means that these angles are the same. So that's 22 degrees right here. Okay, so if this is 22 degrees, can't I go ahead and calculate this distance by subtracting by 180? Or sorry, taking 22 and taking that away from 180? I can, right? And that is this angle right here too. That's B2. Okay, and if you look in your notes, the measurement angle B2, it's the supplement to your first angle B, right? And supplement means they add up to 180, right? So I'm going to say, okay, find the measurement of angle B2. All right, well, that's easy. I take my first B angle. So the measurement of angle B2 is equal to 180 degrees minus the measurement of angle B1. So 180 minus 22. And we get 158. So much easier. Okay, so I know that that right there is 158. Okay, well, I got two angles, so then can't I go ahead, can't I find C2 with the triangle sum theorem? You betcha. Find the measurement of angle C2. All right, so the measurement of angle C2 is equal to 180 degrees minus 158. Doesn't leave us with much. Minus 19 degrees, and this is equal to, I think it's 3. 3, Schwarberg, 3. Do the math. It's 3 degrees. Easy, easy. All right. Okay, so I know that this is 3 degrees. All right, so what are we missing? We're missing side C2. So now I'm going to go ahead. I'm going to say find C2. Okay. All right, well, sine of 19 over 16.2, right? 16.2. You use this, right? This is what's given. That's that given relationship that you just keep going back to. 16.2 is equal to sine of 3 over C2. We'll cross multiply. C2 sine of 19 is equal to 16.2 sine of 3. And C2 is equal to 16.2 times sine of 3 degrees divided by sine of 19, which is approximately 2.6 centimeters. 2.6 centimeters. Okay. Hey, that's it. We're done. Do we stop there? Well, yes and no. I mean, what you need to do is you need to summarize your information, right? So I'm going to say here, okay, first triangle. Okay, I knew that the measurement of angle B was approximately 22 degrees. The measurement of angle C was approximately 139 degrees. Whoa! The lights just turned out. They didn't think I was still in here. Okay, I know that little c is approximately 32.6 centimeters. And then we have our second triangle. Second triangle. Measurement of angle B is the supplement to this first one. So that is 158, approximately, because this was approximate. Therefore, the measurement of angle C here is approximately 3 degrees. And then side C is approximately a whopping 2.6 centimeters. That's it, kiddos. I used the law of sines to solve two different triangles. Boom, in the ambiguous case. We're going on a long time here, so I'm going to go ahead, I'm going to pause the video, and we'll do the last two examples and the practice problem in another video. All right, actually, you know what? I'm going to give you the practice problem right now. Here. All right, here's the practice problem. I want you to pause the video. I want you to try this one, and I'm going to go ahead and share the answers right now. All right, so hopefully you pause the video. Here is the practice, and here are the solutions. Hey, thanks for being super awesome and watching this video and learning about the law of sines with the ambiguous case. Catch you next time. Peace out.